Record. Here we go. All right. So those watching on Zoomlit. Wow, that's a name, isn't it? We just did an element quiz. We got progress, right? We're gonna take two more. Again, we're taking the what score? The best score, right? We're gonna be taking the best score that you guys gave and put those into your grades. All right. Go ahead, Cedric. It is a non-metal. Hydrogen, non-metal. Why? Not that I know of, it does not.
Metallic just H. It acts just like metal. It's not even bonded to itself.
All right, let me come around and double check where we got. So we got to the metalloids, right? That was as far as we got. Okay. So for metalloids, I'm going to sit down because it's easier to draw when I'm sitting down. All right. Mickey, Cedric, guys, we need to stay focused. We can talk about if hydrogen's a metal later. All right. It is a really cool thought, but right now we're looking at what metalloids are. We're trying to focus in here, okay? So we've got our staircase, right? So that's how we figured out the metalloids. Made a staircase. Man, this staircase is really going wobbly. All right. No one wants to climb this staircase. This would be a horrible one. All right. But you guys have this staircase. If you guys don't have things colored in yet, what I want you to do is I want you to color in everything that touches the staircase with a side, except for aluminum. All right, so these are the ones that you should have colored in. All right, let me come around and see how, I think we're just trying to catch up a little bit on that. All right, if you have other ones colored in, you were gone yesterday. All right, let me get you a periodic table. De nada. All right, so yeah, if you missed yesterday, you'll want to go to the Canvas and look up the video that we have for that, and you'll get all caught up. Awesome, yeah, fold that side so it's on the inside. So your hamburger is this, your buns are that.
Oh,
yeah. All right, so that's our metalloids. If we've got this nice little barrier, this border for metalloids, right? What do you think we could say about either side that's left? If we've got, let's see, where's my pen? There we go. We've got this side and this side. Do you think we could group those two sides as something? Yeah, we could. All right, so for the left side, right, if we look at something like titanium or nickel or gold, right? Those are all metals. And so coincidentally, everything on this side are metals, exactly. So what I want you to do is I want you to take your pencil. I want you to just write metals on this side. We're not coloring in the metals, we're writing in. We already did that? All right, I'm just making sure we're all caught up on the same page, all right? We're not going to color in the metals. We're just going to write metal on the left side. And what do we put on the right side? Non-metals. Perfect. All right. So non-metals. All right. Hello, Jordan. Go ahead and pull out your periodic table from yesterday, and we're going to finish it up. So we're not turning in this paper. I think I might have forgotten to mention it yesterday. We can use this periodic table on the test, right? You can use this one on the test, all right? With that said, we want you guys to make sure that you're using everything on the periodic table as we tell you to. So if I tell you to write metals on there, I want you to see metals. I want you to say non-metals because I wrote non-metals. Have I written down the names of the elements on this? Not at all, all right? So if I see that you're writing down the names of the elements on this table, you will not be allowed to use it on the test, all right? I know, it's horrible. I'm so mean, right? You have any of this awesome reference tool that you can use on your test, but I'm telling you, you can't do something to it. I know. No, so you guys are, again, you guys are working to memorize the periodic table. Would you like a periodic table? All right, let's get you one. We got one more right here. All right. Here you go. Fold that up so the big one is on the inside. Oh, thank you. We like it. Awesome, awesome. Thanks for getting that to me, Jordan. All right. So now we've got our metalloids. We've got our metals and nonmetals. We've got all of that labeled. We're going to go ahead and move on to our next thing to label on this. All right. And then we're pretty much home free. We've got like 2 or 3 more slides. It's pretty great. So the next one that we're going to look at is diatomics. Now, who here has never heard that word in their life? You heard, okay, we heard it yesterday, right? We talked like for 2 seconds about it, right? Diatomics, right, as a lot of you guys have 2s in the bottom right corner of 7 elements. All right. So what I want you guys to do, we missed this yesterday. What I want you to do is you've got some space in your periodic table key. I want you to make a square and put a Q in it. All right, Q is the made up mythical element that's yet to be discovered. All right, it's just a placeholder so that you guys can remind yourselves what the 2 and the other things we're going to be adding to it mean. All right, so we've got a Q. I'm going to put a 2 in here. And I'm going to put a little arrow up there and say that 2 means it's diatomic. So I want to remind you, what does diatomic mean? If they remember from yesterday. Oh, yeah, I thought I gave you one before you left yesterday. Sorry about that. Here you go. So anyone remember what diatomic meant from yesterday? I know we went kind of fast on that. Oh, that's okay. So diatomic means that it needs a buddy, right? If I look at something that's not diatomic, let's say gold, right? If I want to get a single atom of gold, I can. It's fine. It's happy. It's not going to throw a fit, right? If I try to do that to say hydrogen, nitrogen, or any of these other diatomic elements that we're naming here, they're going to whine and cry and say, no, I need a buddy, please. All right. And they're going to say, okay, let me have a buddy of myself, right? So you're never going to find an atom of nitrogen. You're always going to find 2 stuck together. All right. And the same goes for fluorine, oxygen, and all the other ones that we've marked. All right. Sound good. Let me double check. Because what? It cares? Oh, yes, they come in pairs. Sorry, I thought you were saying cares. I'm like, yeah, elements, I guess, yeah, they care for each other, if that's how you want to think about it. I don't. Yeah, diatomics have to have friends or else they don't exist. All right. They're like the people that like, no, I need a buddy. I got to go up to the cashier and ask for more ketchup packets. Right? Who else is like that? Right? I gotta have a buddy, ask for ketchup packets. No one else is that introverted? Okay, cool. Glad I'm alone. All right. All right. So now we're going to look at what toxic and colorful elements we have. All right. So just going back here, I'm going to stop walking because I'm feeling like Mercury. I'm orbiting way too fast here. So we've got our element Q. It's already got a 2 in there, right? We're going to go ahead and add a T and a C to it. That's okay. That's all good. As long as you know what it means, you're good. Yes. All right. So we're going to have a T and a C in this Q. All right. This element Q box. All right. I'm going to take a seat right here, if you don't mind. All right. So hope there was nothing breakable in that backpack. All right, so we're gonna have T, C, and our 2 in the Q box. And what I want you to do is draw a little arrow from your T and write toxic. And then for the C, we're gonna put colorful. Oh, weird. All right. I don't know why it doesn't like me. I'm very nice to it. Nope. So we're going to put a T in the ones that are toxic. So titanium is toxic, right? I'm gonna draw them big on here just so you guys can see it. But again, I want you to put it in this little corner. In the top left corner of the elements I'm marking, all right? Same difference. So toxic elements will kill you, all right? So we want titanium marked. We want nickel marked. You guys have heard of lead poisoning, right? Yep, so we're gonna mark lead, PB. Gonna mark mercury. And then we're gonna go in and we're gonna mark fluorine, chlorine, bromine, and iodine. And then we're gonna do selenium and arsenic. All right, let me double check that that's all of them. If I remember right, that is all of them. All right, and you can just use a pencil for it, or if you really want to be cool, you can add color to it. All right, let me double check. I think that's all of them. All right, that is now. All right, when I say that chlorine is toxic, what's something that we know chlorine is in? Pools, right? So does that mean when you go into the pool, you die?
No, every time.
What?
So if chlorine is toxic and then chlorine and sodium make salt, why are we able to eat salt?
Exactly. Yeah, that's a great question. I'm just getting to that point actually. So McKee asked, hey, if chlorine is toxic, how in the world can we have table salt? It's made of sodium and chlorine, right? The reason we're saying these elements are toxic is because they are toxic whether as themselves, right? So if you ingest nickel, right? And I'm not talking about the coins, right? I'm talking about like an ingot of nickel, right? Or lead or mercury, right? If you have it as just the element, it will kill you. Or if you have it in a compound like titanium, right? If you have it in a compound, it will kill you. Now, to your point, does sodium chloride, table salt, kill you? No, you can put it in all the popcorn chips and cucumbers, right? If you like cucumbers, put salt on them, right? Right, you can put salt on anything and you're gonna be fine, all right? Chlorine is bad for you because when it's a gas and you inhale it, it kills you, right? Think about, because of World War I, thank you. So what about titanium? Who here knows someone or has something themselves like a hip replacement, or you've got a screw in your leg, right? Or you've got maybe a titanium plate, right? A couple of people know this, right? When we all get old, we're all grandmas, grandpas, or just old period, right? We might throw out a hip and have to get a hip replacement or get a spine replacement, something like that. We'll get titanium. Is the titanium going to kill us? No, it's the compounds that have titanium in it that are bad for us, all right? Does that make sense? It's not that they're always toxic as an element. It might be just because of the compounds or vice versa. So, all right, let's go ahead and look at our colors. I'm going to switch colors. Speaking of, let's see if we can get this to work. All right, let's go ahead and make it blue, all right? So for the colored ones, we did a lab earlier this week, right? What lab did we do? Sulfur and iron. All right, what was the difference between those two when you just looked at them? Metal and non-metal. I appreciate that, but color-wise, the sulfur was yellow, right? I heard it in here somewhere. All right, what color was the iron? Kind of black, boring. If it was shined up, it would be kind of silvery, right? So when I say something's colorful, right? When I say something's colorful, I mean that it's not silver or gray. All right. So with that, would I put a C for color with the iron? No, right? Because it's kind of gray, right? What about the sulfur? Yeah. All right. So we're going to put sulfur. We're going to put a C for sulfur. We're going to do potassium as well. You guys might not know this, but potassium is, thank you. It's been a long day. Phosphorus is going to typically be red, right? What's on the end of your guys' matchsticks? Phosphorus. Yeah, and it's red, all right? Carbon is going to be colorful. Carbon's black. Is it gray? No. So carbon is colorful.
So if it's not colorful, it's just gray.
If it's not colorful, it's gray or colorless. Right? So like hydrogen, helium, when they're gases, you can't see them, right? All right, and carbon, again, carbon is colorful just because it's not black, or it is black. It's colorful because it's not gray. All right. Now we're gonna say chlorine is colorful. Bromine. Question? I got an answer, Mickey. Go for it. No. Colorless.
It's a gas, right?
It's a gas. So we're talking about things at room temperature as we see them, right? Can you guys see the oxygen in the air?
Yeah. It's got a long distance.
You've got a what?
Light can't get to you through the oxygen.
It changed the, so you're talking about why the sky is blue, isn't it?
Enough oxygen through far enough distance, you'll see it.
Okay, that's not because the oxygen itself is blue. The oxygen is blocking the blue parts of the light from getting through. All right, oxygen itself does not have a color. All right, we're gonna also say that copper has a color, gold has a color, woo,
I love this gold.
and cesium has color. All right, how does that feel, you guys? You guys got that down pretty good? Just marking T's and C's. Dot, you know, make sure you dot your I's. So we got cesium, copper, gold, carbon, phosphorus, sulfur, and then everything between chlorine and iodine. All right, let's move on to our next one. And guess what? This is our last slide. All right, you guys are flying through this. We're doing great. Actually, yeah. So density, right? Density is going to be pretty easy to mark on here, all right? What I want you to do is go to your key to your markings. Pay attention, guys, please. So I want you to write down density, right? And what I want you to do is I want you to draw 3 arrows, all pointing towards, not manganese, sorry. Misreading my own notes here. Oh, okay, don't use pen on this, guys. All right, I want you to put it towards nickel. All right, 2, oh, okay, 2 towards it, and then 1 down. All right, 2 towards it and 1 down. All right, and then if you want to put it on your periodic table, this is what you would do.
Wait, so we want to point it at nickel?
So you want 2 pointing at nickel and then go down for your 3rd arrow. Let's see. Okay, nice. So this means that nickel is going to be more dense than cobalt, right? Where was cobalt in reference to nickel? To the left of it, right? So that what we're talking about here with these arrows, and you'll see this with your melting points too. The arrows, where's my pointer? Arrow means highest at the point of it, right? So if nickel is at the point for these 2 arrows, everything horizontally is going to increase in density along this or towards this area, right? Not quite. So look at our 3rd arrow going up and down. Which way is it pointing? Yeah, the down arrow, right? It's pointing down. The heaviest ones are going to be in this area, right? In this area. All right. So again, we grow towards nickel, we get denser, and then we start going down and we get more dense. So with that, is platinum more or less dense than nickel? Right, it's more dense. Good job, guys. All right, so then this one will be a really easy one. Is lithium more or less dense than calcium? Or sorry, potassium. It's going to be less dense, right? Potassium's with a K. Go ahead. Luke? What do you mean go like? Kind of. I mean, so the way these arrows are, we can add, if we wanted to, we could add more arrows. We could say, oh, okay, density's still going, increasing towards this center part. All right. Yeah, so with that, would tungsten be more or less dense than nickel? Tungsten, it's more dense, right? Because it's lower than nickel, right? Right, gold is more dense than that. Good job, guys. Good job jumping to that, all right? All right, let me erase some of this, just kind of clear it up a little bit, clean it, make it look pretty again. Oh, I miserased one. All right, let's get that nickel one going there again. All right, so I'm going to change colors. Someone yell out a color other than yellow for me. Green? All right. All right, so we're going to look now at melting points. All right, let me erase this up here. You guys all have that, so I just need a little bit more space to write on here. All right, so for melting points, what I want you to do, again, fill this in on your key to markings, all right? And what I want you to do is we're going to have two rules with this. All right, we're going to have a rule for metals and a rule for non-metals. Yes way. All right, so we're going to have one rule for metals and one rule for non-metals. For non-metals, it's pretty easy. It goes down. All right, so if we wanted to start with fluorine, we would just draw an arrow. That's a horrible arrow, but we're going to go with it, right? We would go down from fluorine, right? Does that kind of make sense to you guys? If we look at fluorine, what state of matter is that? It's a gas, right? So gas up here. What about bromine? What state of liquid, or what state of matter did we say bromine was? Liquid, right? All right, so we'll put an L. And then what about iodine? Solid, right? So if something, how do we know it's a liquid? So that's a good question. So melting point can also be known as, guys, stay with me, Ike in your group. All right, gotta pay attention, please. So melting point, you can also call it a freezing point. All right, so the way they figured out the melting point for bromine was they tried freezing it. All right, so the higher, or oh, sorry, I have this backwards again. So the higher the melting point, the more likely it is to be a gas or a, let me restate. So the higher the melting point is, the more likely it is to be a solid at room temperature. No, I got that backwards again. I can never get this right. Sorry. I know. I'm this one trips me up. I'm sorry, guys. All right. Fluorine has a higher melting point. Fluorine has a higher melting point.
Wait, how does gas melt?
Again, to figure out the melting point of something, you can also figure out when it freezes. How do you get it really stinking cold? All right. Have you guys ever heard of liquid nitrogen ice cream?
Yes.
Right? What state of matter did we say nitrogen was? It's a gas at room temp. When I'm talking about, when I ask what state of matter something is, I'm talking about on the periodic table.
Okay.
When we're looking at our periodic table, it says that nitrogen's a gas, right? When we try to get nitrogen to be a liquid, it gets really, really cold. All right. If we're trying to freeze something, right, we have to get it to the freezing point, right? What's the freezing point of water?
32.
32 degrees Fahrenheit, which is a big no-no word in here. It's 0 degrees Celsius. Yeah. So is the melting point and the freezing point of water the same?
Yes.
Yeah, it is. If you take ice and you put it in a 32-degree room, it will start to melt. If you put water in that same area, it starts to freeze. All right. Melting point and freezing point are the same thing. So that's how we figured out that fluorine has a really high melting point, right? It melts, and in fact, it vaporizes at room temperature, right? Bromine just melts at room temperature, whereas iodine stays solid at room temperature. All right, so we want this arrow pointing up. Forgive me for getting it wrong the first time, right? Most of you guys are using pencils, you could fix that, all right? But again, non-metals, we get that fixed up here too. All right, non-metals have higher melting points. Oh gosh, Mr. Davidson, correct me. I can't keep this straight anymore. Okay, I've been getting this backwards all day. Okay. Because like I've gone through 3 periodic tables, drawing it and labeling it like you guys, and I still don't have it right. Oh. So it should be going down from fluorine. I had it right. Okay. I just gotta not second guess myself on this. Okay. So highest high melting points at the end of the arrow. High melting points down here. Acetine has a high melting point. All right, it's going to take a lot of energy to take it from a solid to a liquid into a gas.
Okay, so final answer is metals have a lower or higher?
We haven't gotten to metals yet. We're just on non-metals. Non-metals.
Lower. Okay.
All right. For metals, all right, this one I know. This one's good. Took me a while to get it. I want you guys to do.
Whoa.
Okay. Stay with me, guys. All right, you're going to put manganese at the center of 3 arrows. All right, you're going to do an arrow towards it there. We're going to do an arrow towards it here. And then an arrow going up towards it. So what does that mean? That manganese has a higher or lower melting point than chromium? Does manganese have a higher or lower melting point than chromium? It's the highest, right? The points of these arrows mean the highest, all right?
Okay, that makes sense. That makes sense. That makes sense.
No, it is not a liquid at room temperature. All right. So we'll go over this again on Monday because that got a little messed up. But yeah, go ahead and study that. Again, we're having an element quiz on Tuesday. So find time in your homecoming festivities to go over the Quizlet, make some flashcards, do something to make sure you know what all the elements are, all right? Thank you.